sound is working. Great. Let's just check the quality real quick. Is working. Great. Okay, it's all good. Sorry for this. I had some kind of issues with the microphone, but I think everything's okay now. So today's stream is slightly later than before, and that is because I had an accident at work, and I had to go to the doctors instead of streaming in the morning. But I can have a little stream now. I might need to take some breaks here and there, but I think we can squeeze in the hour. So for today, as planned, we are doing the Pathfinding game, and we'll be doing the setup. So before we start, you will need ProBuilder for this specific one. Now, I already installed one because it takes too long. So the way you do it is you go into Windows, Package Manager, and you just search for ProBuilder within your packages, and then you install it. And once you have it installed, all you need to do is go into Windows and then to Tools, and then you'll have ProBuilder here. Click on ProBuilder window, and a little window like this will appear. So that's the only prerequisite for this specific series. I actually also have an image that I'll be using as a little selection tool for our objects. So I'm going to put it here. So let's start off with creating some folders. So create our resources, our scripts, our prefabs, and that should be good enough for now. And of course, we want to do a little underscore here. For scenes, let's create a scene and call it test nav mesh. And that's the scene we are going to work on for now. So to start off, we will create a very simple 3D plane, like so. Let's make it slightly bigger. Cool. And let's get straight to programming. So what we want to do is, for this series, is to create an object which can move around with our mouse click on our terrain. So let's create a capsule, which is going to be our controllable character, like so. And our controllable character will need two sets of scripts. One is going to be our own script. So let's create it first and call it the, I guess, agent controller. And let's drag it straight away into the project if Unity stops lagging. And then we also need the navmesh agent component attached. Now, if we just disable the capsule collider, we see that our navmesh object draws a little cylinder, which is our navmesh collisions. We can change that by moving our offsets speed, which is used for moving the agent, etc. So yeah, let's open up our script and do some code for a simple code for our agent. Okay, every computer seems to be loading extremely slowly today for some reason. Hello. Come on. Okay, so what we will of course need to do is have the reference to our agent. So we'll have to have a private nav mesh agent. And that requires us to use unityengine.ai. And we're just going to call it agent. And in start, we'll just do agent is equal to this.gameObject.getComponent nav mesh agent. like so. And with this, we've connected our agent. Now, let's also make a serializable field, and let's call it private game object, and that's going to be our destination target. Let's actually change this to a transform, like so. And now what we will simply do is, for now, to keep it simple and show how it works, is if destination target is not null, then agent.enabled is equal to true, and then agent.destination is equal to destination target, like so. And this, I believe, takes in a vector 3, so we'll just do dot position. And on start, let's just do agent.enabled is equal to false, like so. And then agent.isOpt also. Actually, let's leave that out. So now let's give this a try and see what's going to exactly happen with our code. So first thing we want to do is create a new object. Let's just create a cube for now. And let's call it our target. And click on our controller and drag over our target, like so. Now that we have this, let's press play and see what happens. And actually, let's set up the camera to view our entire plane. Could actually position it as 0. You guys go at 0, 0, 0 as well. Where are we? Let's move you out. And let's move you here. Okay, so anyway, we still had the error. So set destination can only be called if an active agent has been placed on a nav mesh. So what does that mean? It means that there is no nav mesh created. Basically, think of it as a walkable floor. So now let's create a walkable floor for our component. And that is in component navigation. And is, oh, wait, I think there was a different way to do it. Add a tab. It's been so long since I did this last time. Where was it? Actually, one thing that we'll need to do is, I believe, we'll need to set our floor. So let's rename the plane to rename as going to be the navigation floor. And if we go here, where are we? No, where was it? Static, we need to set it to navigation static, like so. Where was the thing that I'm looking for? How do I add the navigation tab into the inspector? Is there no navigation? Navigation. That is so not it. Wait, window AI. Oh, there we go. That's the one. Now it's docked in here, so we have our navigation tab. So let's go over it. So agent is what our agent settings and how it's going to work. So the radius, how tall it is, how big the surface can be for it to be considered a step, so we can step over it, and how big a slope can be if we want to go up the slope. If we go into bake, this is what we're actually interested in. So baking will create our little Again, there you go. We have so navigation area. Those are free states of where we can walk. It's not walkable and can be jumped on. So let's just click bake and see what's going to happen. Now, if we see this created a blue area, if we now press actually play and see how our character will behave differently, now we can see that our character is moving straight to the cube, or to be precise, our target, and it will follow and path correctly based on where the cube is. Of course, if the cube is in the air, it'll just still move to that position, but of course it's not going to leave the nav mesh area. Now, where are we? Now, there's other options that we can modify. So let's just do 0.25, clear and bake. Change that to 30, for example, clear and bake. But no, let's keep everything at default. Actually, yeah, there you go. If we change the radius of the agents, the corners will get smaller. There's actually another thing that we can also place. So if we just duplicate our target and call it terrain blocker. So if we look at the nav mesh now, if we clear and bake, our cube that we just actually one more time, our cube is not impacted by our nav mesh obstacle. So let's press play and see how our agent's gonna react to it. Now it just went straight through the cube, right? Which is not exactly what you would want if you would want it to be an obstacle. So NavMesh has a third option, which is called the NavMesh obstacle. And if we press the carve button, and we go back into our, where are we? The navigation tab, we now see that we have a box around it. And if we press play now, our agent is gonna move around it in the most optimal way because that's in the way, so it's ignoring it. So what we can essentially do is create terrain that will be automatically carved into our map that will prevent our agent from walking incorrectly. Let's fix the camera so the camera is looking up on our entire project real quickly. So let's just give it a minus. Come on. Where are we? Yeah, let's make the camera look at the entire thing from below. Maybe 66. So just so we can see the entire map. Let's play with this a little bit more. Let's create a little set of terrain like this and see how our agent is going to react to it having to move in between these points. A bit smaller. There you go. And let's give it a play. And now we'll see that again, our agent takes the most optimal path to reach our area. If we click on the agent itself, where are we? Controllable target. We have all of these options here. So angular speed is, so let's play with these values and see how that's going to impact him. So let's change this to a huge number. We see that we really take a quick turn at the angle, etc. So those are all nice things we can play with. Auto braking means slowing down before we get to the target. So let's remove it entirely and see how that's going to impact our object. And of course, stopping distance is how early do we stop in front of our target. There you go. See, we overshot the target and we keep moving backwards and forwards because we don't have auto braking enabled. So with this in place, let's do two things. First, let's remove collision from our target. Secondly, let's now click on our agent. Actually, let's create a new script and call it the player input controller. And what the player input controller will do is it will handle the clicking of our agent. So what we want in our player input controller is to have a private game object transform, and let's call it the, actually let's do, let's do private agent controller selected agent. So this will be the agent that we select, and let's create an update function and do private void left mouse click, and call the left mouse click in update. And what the left mouse click will do is it will, of course, do our little left mouse click. So what we need to do is input dot get mouse button down, and then 0, as that's what left mouse button is. And then we can do our little piece of code which will handle our input. So first, let's store in our, let's do a raycast. So ray is equal to, and then we need a reference to a camera. So let's just get our main camera, private camera cam, and create a start function which will say camera is equal to camera.main, like so. Reference to the main camera, reference to selected player agent, and then let's continue on with our raycast. So we'll do camera.screen to screen point to array, and then we'll do input.mouse position like this. Then we'll do raycast hit, and then we'll just check if our physics.raycast ray out hit, and then let's call it, just do a random number here, like 100. Let's actually add a mask for what we can click on and what we can't. So let's do serializable field private layer mask, and let's call it the interactable mask, like so. And let's add this to our final condition in our physics. Now, so we don't forget, let's add our floor as a interactable layer. So let's go here and let's call it walkable layer, like so. And let's click on our navigation surface and change it to walkable layer. And if we click, now let's create a new empty game object and let's call it the game manager. I'm just going to reset the transforms on it and attach our player controller input and set the interactable mask as a walkable layer. And now that we have this, let's do if our hit.transform.tag, and we're going to make it equal to a specific tag. So we have to make sure that what we've hit is our character. wait. Oh, that's right. And let's think of some sort of a tag that we can use. So let's call it a unit, because this is not going to be our player itself, but it's going to be one of many units. And set it to unit tag. We have a little bit of yellow errors, so can I set this to null? Nope. Can I set this to 0? Yep. Okay. Now with this, what we'll do, if it's a unit, then then we know that if it's a unit, it will have to have our agent. So our selectable agent is going to be equal to hit.transform.getComponent, and we will look for agent controller, like so, because that will get that specific unit in. Now, let's add a little bit a selector that will be selected on and off when we know. So if that it has been selected, so let's now create a new script called selected interactable. This is something actually we've done previously for selecting of towers. So what we'll do is we'll have a serialize field private game object, and that's going to be selectable. And we'll create two sets of functions for public void enable selection, as well as public void disable selection, like so. And we'll also have a start function where we automatically disable it. So stores the reference to game object which enables select, which shows if the unit is selected, handles display of selected object, and we can get rid of all of that. Now in start we will disable selection, disable selected object by default, and then runs when the object selection has to be enabled, runs when object selection has to be disabled. So now we can just do selectable object dot set active true, and we will do the reverse in here by setting it to false. With this done, we can close the script and never look at it ever again. And all we have to do is just go into our target. No, into our where are we? Controllable character, and add a selectable interactable to it. Of course, now we need a game object that has to be attached. So now let's create a canvas, change the canvas to a world space, and let's give the canvas an image. Where are we? Like so. Make the image spread across the entire canvas. Now let's go into, let's drag in our selector and move it into resources while we're at it. Now we have this big circle, but what we actually want to do is preserve the aspect ratio of it and make the entire canvas itself. Let's call this selectable, image selectable, and then canvas selectable, like so. Now let's make the entire canvas smaller than this, smaller than this. Where are we? Smaller. We also need to rotate it 90 degrees. Let's look at the project from above. Let's zero the position, which is perfectly in the center, and make it even smaller, just enough to fit around our selected unit. Now with this done, we can move it down, although I'm a bit worried that we're, there we go, at the incorrect axis. And with this, we have our little selection circle done. Now let's go here, and what we'll disable is not the canvas itself, but just the image on the canvas. So it's going to look something like this. Now if we now let's add a little bit of code that will handle it. So if selected agent is not null, then what we'll do is selected agent dot game object dot get component, and we're going to do selectable. What is the class called? Selected interactable dot enable selection, like so. Now with this we should be able to select our object, so let's just do that. If we actually, I've just realized we've made a little bit of a blunder. Where are we? And change a layer here to selectable layer. Let's go into our player input controller and change this to selectable mask. Now let's go into our controllable character and change his layer to, nope, I'll need this. So if I click, let's remove, where are we, target. Let's remove it, untick it from our character. Let's nullify it. And now let's perform a click, which doesn't seem to be doing anything. Because we didn't change the mask, did we? Where are we? Like this. And with this, now we have our little character selected. One thing that bothers me is the perspective camera. So let's change that to orthographic. There we go. And with this, we have the selection done. So now we just have to move our character around. Let's actually create a second one, because right now there is going to be a few issues. So for example, if we select the first character, he gets selected, but if we select another, he gets selected. Now, of course, in code, this will override the previous character, but this doesn't actually show us who was previously selected. So let's just do a little bit of cleanup code that will deselect something. So if our, what do we call it, selected agent, if is not null, then what we want to do is we want to deselect this agent. So we will just do this piece of code here in the reverse. So disable selection, and that will hopefully deselect it, and we'll do selected agent is equal to null, like so. Another thing that we also want to do is do a little thing at the beginning, which will do So what this will do is it'll remove any clicks on UI. If we choose to have UI, it's just a nice piece of code to have. So what this does is if we click on UI, it's gonna the cast is not gonna go through. So let's just add a little bit of commenting. So controls all the left mouse clicks. Makes the raycast not bound. Mouse clicks not bounce through UI elements. Deselects already selected characters before making a new selection. And then choose a ray cast to find new selectable character. And with this, the selection is slightly less prone to error. So let's give this a little quick play. So if we click on one character, then we click on another, it deselects it as it should. Now, with this done, let's move on to the next part, which is going to be the creation of the right mouse click. So what I kind of want to do is just do, since this code will be quite long, I want to split them into regions. Then handles right mouse clicks by the user, like so. Of course, we want to call right mouse clicks as well in here. And with this, what we are going to do is handle everything that we need for moving the character forward. So again, just like in our previous example, we can pretty much copy a vast majority of this code. Well, at least the raycast part. So let's just do this, remove all of that for now. And let's remove the entire content of selection, like so. Change this to 1. And now we have our right mouse selection done. And what we want to do is first check if our selected agent is not null. And instead of clearing it like with the previous example, we just want to move that agent. So what we will do is we will simply move him to that specified point. So what we can do is essentially just do selected agent dot, and this is where we will have to have access to our navmesh agent. So rather than having access to navmesh agent, let's create a function called public void move towards. Move the agent towards, and this moves the agent to specified coordinates, like so. Now this handles the movement of the agent, sets up the agent's default behaviors, reference to the agent script which handles movement and pathing, stores the destination object which allows the agent to move to a location, like this. Now, what games usually, so to get our clicks to work, what we will have to do is pass through a position. So if we go back into our player input, and all we have to do is move agent towards, like so. And this will take, let's just say it will take a vector-free destination, like so. Now, and we will pass through hit.transform.position. and this will give us a position to move towards. Now, what this will then do is it will let's get rid of this. Well, we'd actually don't need the destination target for now. So it's not necessary. So let's create a boolean instead and call it bool. Private bool has destination, and by default we will set it to false. And what we'll do here is change this to if has destination is equal to true, then we can enable it. And in here, we'll be setting our destination. So we'll do agent.destination or set destination, a destination, like so. Then agent.enabled, we're going to set it to true. And then what we'll do here is we'll do if our we have if agent dot, let's just do it if vector free dot distance, and we'll do this dot transform dot position, and then another one is going to be our agent dot destination, and we're going to make it smaller than 0. And let's just do a quick test just to get that number right. Then we'll do debug.log within bound, within destination, like so. Now let's give this a quick play. So let's click and right click now, and nothing has happened, which is interesting. Oh, it is interesting because we're doing a selectable mask. So let's change and add another mask. So we have a selectable mask, and we'll change this to the pathing mask instead. And in the right mouse button, we'll change this to the pathing mask. And then in the game manager, we set the pathing masks to our walkable layer. This will prevent clicks on walls. So if you click and right click, well, it can only be called an active agent that has been placed. Oh, are you not placed? What's wrong here? Have I placed them too high? Perhaps? No, I think we have to enable the agent first before we set the destination. So destination to true. We actually need to also has destination. It has to be set to true as well, like this. There we go. So the agent moves. Of course, it doesn't move exactly where we would want it to be, but that's fine for now. That can be very easily changed, because what we did here is we did hit.transform.position, but what we really need to do is hit.point. I like this. Now the reason why, because hit.transform.position was getting the reference to the point that we clicked in, rather than what we wanted it to be. Okay. Put the sign in the wrong order because it has to be smaller. The distance has to be smaller between them to be signifying the end of the path. And now it's never signifying it, which means that 0.15 is too small of a click. Is it? Interesting. Right, if the so vector free distance, if the distance between these two is bigger than 1, no, because that will always be the case. But why does it not? Confusing. Okay, either way, I guess this doesn't work for now. Let's actually keep it in. So with this, we do have our movement and down. It needs a little bit more work. So one thing I want to change for this is, usually in games, we know the position that they will move to by some kind of a destination tracker. So what I do want to add to each of these is their own little tracker of where they go. So let's go into here and create something that would look, I guess, like a position flag. So let's create the 3D object, create a cube. I'm going to make it 10 times smaller, but as long as our character, like this. And let's rename it to the destination flag, like so. I'm going to disable collision from our destination flag, and I'll actually create a second cube. Which will make it look a little bit more like a flag. Where are we? I'm going to purposely leave a little bit of space in between and drag the bottom bit to be slightly smaller, like so. Now let's add some materials into the project by going here and creating a folder. So this is going to be the 2D assets, which is where we can grab our selector, and let's create some materials. Because right now everything is very hard to tell apart. So let's call it the flagpole. And since it's a flag, let's make it, I guess we can keep it as a gray color. And the flag itself, for the destination, we can make it, there's some issues with the light with this project. It looks off, as crazily off, but whatever. Let's use a red color for our characters. And the characters. And let's create a floor object as well, and something for walls. Floor. We'll have a static walls, and then movable walls. Okay, the floor is going to be purple. I don't know why, it just is. Let's pick blue for movable walls, and then make a cyan for every other type of wall, like so. Okay, with this done, what we'll essentially do next is, if you've played any RTS game, when you select the character and click, the flag shows where they go towards. So we will make it so that every single flag corresponds to our character that moves. So we can move them all around and each flag will show where they path towards. And of course they will move path towards the flag instead. So let's remove our other character and drag our flag into our character. Set the position as 0, 0, 0. Oh, we didn't parent the cube with the flag. It's now slightly off. There we go, like so. So in our character control agent controller, we will create a brand new object, and we will call this object private. Let's make it a serializable field. So private game object destination flag, like so. And what we will be doing here instead is setting our destination flag .transform.position to destination flag.transform.position is going to be equal to our destination. Of course, at start, we want to disable our little flag, so destination flag.transform.position is equal to false. What? No, dot set active false, like so. And with this, our set destination is going to be our destination flag.transform.position. Now, in theory, this makes no change to the code itself. It will still function the same way, but now we move towards the flag as opposed to the actual object. And of course, this will change for our flag.transform.position, like so. Now let's set it up and attach our flag to our object. Of course, another thing that we have to do is we have to set our destination flag.gameObject to true upon our agent getting getting the command to enable it. Now let's press play. So when we press play, the flag disables. We select our object and we have a slight issue because our destination flag is part of our character controller. So the flag will move if the character moves. So one thing we can do is we can drag the flag out of the controller, but of course that will have its own implications as we will later on we will need to have a flag per object, which is in a sense it's fine. So there we go, we move it here, we go to the object, we move it there, and it keeps changing with the flag moving. Back to the implication is that we always have to have a flag per object. But what we can change later this too is to separate the controller from the object itself, and that will fix itself as a problem. But I guess this is something we'll work on later on when we have more objects to control, etc. Now, so since this project is going to be a puzzle, it's going to be based on controlling the units, so we need to get the movement down. Well, how much? We have 10 minutes of this session left. Let's see if there's anything else that I wanted to go over, because we actually got everything to move, just like we wanted to. We can select. What else would there be? I believe that's everything for. Oh, hello. Follow the set active true. Follow dot set active. I've never heard of that one before, I think. hello, person in the chat. But yeah, in the next part, which is going to be on Tuesday. Yes, Tuesday, yes. I'll be doing drag selection. So just like how I selected in the inspector, we create this little box. So we'll be able to drag select multiple characters. Oh, hello, hello. Nice of you to come in as I'm about to finish it. But yeah, for next part, we'll be adding drag selection. And once the drag selection is complete, we'll be starting to add some puzzles and make the levels within ProBuilder to make the entire project work. Oh, it's a joke. If only it was that simple, right? But yeah, thanks for popping in. This is what I do is I do little Unity streams where I try to make various projects. This is my second project that I'm doing. Within the week, I have three different projects that I do. One is a Pokemon-like clone, which I'll do in about half an hour. I'll be taking a break to have some food, and once I'm back, I'll be continuing on with the Pokemon clone. This is a little pathfinding project that I'm doing, and aside from this project, there's also a little Mario clone, but that's starting on Monday. I usually stream between 10 to 11, which is GMT 0 time. But I've been in an accident at work, so I have a full day off. And since I was unable to stream in the morning because I had to go to doctors, I decided to do several short streams today um, in the afternoon, which is what I'm doing. But yeah, man, thanks for checking this thing out. I'll be going off now. I'll be coming back and we'll be continuing on with part 2 of the Pokemon clone. If you're interested in seeing my first project that I did on Twitch, I would love to see that. I would love to say that there is a link, but there ain't. But I'll be working on it soon. But yeah, thanks for checking it out, man. Have a good day.